It's currently printing at a speed of 150 millimeters per second with an acceleration of 3000 and with a travel speed of 200 millimeters per second, and the retraction is 0.8 with 40 millimeters per second, and the overhangs are printing better even without supports. The main motto of the project is to convert Ender 3 Max to a direct drive extruder and also to use filament runout sensor and utilize complete build volume of the 3D printer. These are the number of prototypes that were designed and tested on the Ender 3 Max, and this is the final design which has been printed in ASA at 300 degrees centigrade. And what materials can be used for this bracket? You can use any hard material like PLA, PETG, ABS, ASA, polycarbonate and carbon fiber. So any hard material will work. And after printing the model, make sure there are no under extrusions. So if there is an under extrusion, the model can be easily snapped off or break. And while removing the supports, make sure to remove them from the top. If you remove it from the bottom, it will create a leverage and will break the top portion. So make sure to remove the supports from the top. Okay. And what are the prerequisites? The prerequisites are a PTFE tube of 8.8 centimeters and an extension cable for the filament runout sensor which is of 24 centimeters, and an extension cable for the extruder motor which is of 34 centimeters in length. So how can you make these extension cables? You can buy them or you can make them. You can buy the clips and crimp them to a cable, or you can directly use jumper wires. These are the jumper wires. You can directly plug them. Make sure to note the color coding. You can use any color coding, but make sure the right pin goes to the right slot. And to secure the bracket, you need 2 M3x10 screws which will be like this. So if you don't have these screws, no problem, you can utilize the filament runout sensor screws. The filament runout sensor will come with 4 screws, but 2 are enough to secure it. So we will remove these additional screws and will use them to secure the bracket to the X carriage. Okay, let's go. Hi. After 3D printing the bracket, make sure it doesn't have any under extrusion. After that, remove the power supply cord. If you are having a dual Z axis, the power supply cord will be facing towards you. Or if you are having a stock Ender 3 Max, the power supply cord will be facing towards the right side. After that, remove the PTFE tube. You can keep the spool holder on the side, or you can remove it and place it on the top. Make sure it locked firmly on the top. If your lock is broken like this, You can download and print it from the link given in the description. After that, remove the extruder fan case and place it on the X gantry. Remove the silicone cover and then insert the PTFE tube by pressing the top part like this and insert the PTFE tube as hard as you can. After inserting it, secure the tube with the PTFE tube clip. Then don't forget to tighten the nozzle. Why? Because it may look it is fully closed but it is not. So to do so, hold the heat block with a pucker and then turn the nozzle as hard as you can so that it won't cause any leakages. After tightening the nozzle with a pucker and a wrench, don't forget to insert the silicone cover. Okay, after that, take the fan carriage and then place it in the original position and then slide the, so here is the sliding part, slide the bracket on the X carriage just like this. Make sure the cables go on the open side without any interference. Sure the bracket holes matches with the fan case holes. The bracket will go on the fan case and will get locked over here. Insert the screws on the two holes. This is the rear side of the 3D printer. So after inserting the bracket, take the extruder mounting bracket and then press the PTFE lock and then insert the PTFE tube into it. Like this. After that, insert the PTFE tube clip. If you are unable to insert the PTFE tube clip directly, use a nose plier or use the filament cutter like this. The clip is just to secure the PTFE tube and it is not absolutely necessary. After that, insert the extruder motor by the pins facing towards the right side and flat head screw on top and button head screws on either side of the bottom. After that, insert the filament lever spring screw from the given slot like this. After that, insert the spring and filament guide lever. After inserting the filament guide lever, make sure the extruder gear is exactly against the idler. If not, adjust the extruder gear by loosening these screws, and then you can adjust the height of the gear. After that, insert the filament runout sensor. The filament sensor arrow should be facing downwards. So after installing the filament sensor, secure the cables by the holes provided at the bottom of the bracket and on the top of the bracket in this way. After that, insert the extension cables for filament sensor and extruder motor. As we discussed earlier, use the color code matching to insert the cables. For the filament sensor, the red wire goes on top side and black in middle and yellow on the bottom. See which way it should be inserted and make sure the right pattern is achieved. And for the extruder motor, there are 4 wires. So note the slots where there are wires and insert the jumper pins and match the right slot to the right pin. For here, the top wire is matched with a brown color and the brown one goes on the top pin. And in second slot there is no wire, so we will skip that pin. And in 3-4 slots we have given orange and white, so skip that pin, orange, white. And on the bottom there is one wire and we have given this purple color, and that goes to the last pin. After inserting the cables, secure the cable with a zip tag and then use hot glue to make them bond tightly so that they won't be removed while printing. This is the complete build volume of the 3D printer. The Z-axis to 340 mm and X to 300 mm. Make sure the cables are firmly held. You can use a heat shrink wrap or a glue gun and secure the cable from bottom of this bracket. Only secure it when you have achieved full build volume so that there won't be any tightness in the wire. Let's see. No problem. So all the way to 300. Already on 340. Let's move a bit downward. And let's again go back to 340. After installing the bracket and securing everything, there is a latest firmware of Marlin available in the product description. You can download it and install the latest firmware, where the firmware has input shaping enabled. you can print up to 150 millimeters per second. After installing this, run a E-step calibration test and X input shaping and Y input shaping, and also do a pressure advance test, retraction test, flow rate test, and also do the acceleration test. That's it. Thank you.